This video will be the first in a series of 5 on the 5 different reaction types. The goal is that you'll be able to determine the reaction type based on these videos, and then also be able to create a complete and balanced chemical reaction for that particular reaction type. So your first reaction type is called synthesis or combination. And essentially, these reactions will always be 2 elements coming together to make a compound. Okay, so in general, there's sorts of formatting issues, but in general, it's 2 single elements, A plus B, and that will create a compound, AB. Okay, so if it's water, that would be hydrogen and oxygen coming together to make H2O. If that was carbon monoxide, there would be carbon and oxygen coming together to make CO. So it's always the synthesis, the bringing together, the combination of simple things to make something more complicated. In terms of being able to identify the type of reaction, you will know that it's this reaction because it will be 2 reactants, and they'll both just be single elements, right? Just iron, just oxygen. We're going to assume in this class that these reactions always happen, which will become more important later. And then the one thing to notice here is that sometimes your single reactant will be a diatomic, right? So that HNOF ClBrI, that HNOF17, if you have them as one of your reactants, the formula for those will have a 2, a subscript 2. If you have something like sodium, iron, zinc, they won't have the 2 because they're not diatomics. Chemically, here's a picture of what that would look like. If potassium, which is in solution, gets mixed with chlorine gas, which is like a yellow, not good for you gas, those 2 atoms would come together, synthesizing and make a compound. What we're going to practice here is writing those complete and balanced chemical reactions, okay, creating the products for a reaction. The way you go about creating complete and balanced chemical reactions is to do what this procedure says. So step 1, you're going to create chemical formulas of the reactants. So using your periodic table then, aluminum is just Al, and iodine is I, but it's one of those diatomics, so it's going to be I2. Okay? Putting my arrow in to represent the fact that I'm going from reactants to products. I know that this is a synthesis reaction because number 1, it's a synthesis video, and number 2, it's 2 simple elements. Okay, so essentially aluminum and iodine are going to come together into one compound. Now, one thing I like to say is as my elements come across to the product side, any subscripts generated based on charge or because they're diatomics, they don't carry over. Right? I did not write a 2 on the iodine on this side. But once I've made the products and created new compounds, I do need to regenerate subscripts based on charge. So charge on aluminum then is always a +3. Charge on iodine is always a -1. So the chemical formula for the product created here, aluminum iodide, is Ali3. Okay, so that is numbers 1 through 3 on this list. Then you always have to balance because right now, conservation of mass wise, this reaction is not right because I have 2 iodines on one side and 3 iodines on the other. I don't fix that by going, oh, I guess that must be on 2, because I have to make the right things and then balance. I can't decide like, oh, in this spinach recipe, instead of using spinach, I'm just going to use bacon. I mean, delicious, but not the recipe. So to balance this, I would need a 2 and a 3 to get that up to a 6 and 2 aluminum. Simple as that. For the next one then, step 1 is to determine the chemical formulas. Magnesium's Mg, phosphorus is just P. It's not a diatomic, nothing needs a 2. Synthesis reaction, the 2 elements come together into one compound. Now I have to generate subscripts based on charge. So magnesium is always a +2, phosphorus is always a -3. So the subscripts needed for this then would be a 3 here and a 2 there. So when magnesium and phosphorus come together to make a compound, that's how they do it. Now, conservation of mass wise, I'm not good because the numbers aren't right. So I'm going to go through and balance. Okay, and that's the recipe. Again, balancing is about doing the recipe. It's like No, you don't use a cup of butter and a cup of sugar and a cup of baking soda and a cup of salt in your banana bread recipe, because that would be crazy. Okay, so it's not a 1-to-1 magnesium to phosphorus, it's a 3-to-2. Copper metal is just Cu. The metal just indicates that it's a solid. Bromine is a diatomic, so that's going to be Br2. They're going to come together into a compound, CuBr. And then because I made a new compound, I have to worry about charges. So copper's a +1 because I gave it to you. Bromine's always a -1 because that's what is on the periodic table. So they're happy, just at a 1-to-1 ratio. So last step is I have to balance because this is not the appropriate recipe. So there you go. States of matter is something that tends to be a problem for everyone in this unit. So just quickly, states of matter are what they are at room temp. So for synthesis reactions, when you make a compound, the compounds you make are going to be solids because ionic compounds are solid at room temp. Usually your single elements, it just depends on what they are at room temp. So my table is not color-coded, but the majority of the table are solids. So all of your metals are solids, and even most of your nonmetals are solids, okay? The halogens tend to be gases. Fluorine and chlorine are gases, and then bromine's a liquid and iodine's a solid, but if you gave me all halogens as gases, that'd be fine. Essentially, most of your diatomics are gases. So for the elements in terms of the states of matter, metals will be solids, and your diatomics in general will be gases. And if you gave me those for states of matter, I would be fine. So up here on the ones I've already written, aluminum would be a solid, magnesium would be a solid, iodine technically is a solid, but if you gave me a gas, I would take it. And then all of your ionic compounds are solids. Okay, so that's how you do states of matter. That's it on your first video about synthesis. Go ahead and do the practice and have a nice night.